Welcome to uh, my series of AI videos. This is the next video in the series, and this is the second video in the LangGraph series. In the earlier LangGraph 101, we saw the basics of LangGraph. Now we'll see more further concepts in LangGraph. Okay. So in the basic concepts that we covered in 101, right, we saw the LangGraph is basically having nodes, edges, right, a state, and then we loop through this. Okay. Now you can print this graph with this image and display, right? And this is how it would look like. Right, so this is depicting a typical chatbot, right? It starts, it enters the AI assistant or a chatbot node, right? If there is a tool call, there is a conditional edge, right? And then it comes back, right? Keeps looping and then it exits, right? When it's done with this, okay? So those are the basic concepts that we saw in LangGraph 101, right? Now, in this video, we are going to see more advanced concepts, okay? So let's start. The first one is the tools, right? So as we saw, right, you have to make a tool call. Now, how do you do that, right? So you basically, from the LangGraph pre-built, you have to import tools condition and tool node. I've defined three mathematical functions in Python, right? Put them in the list, call them tools, right? Now I created my LLM, right? Now I have to bind the LLM to the tools that we have defined. So now we are ready to use these tools, right? Now our AI assistant can call these tools when required. Okay. Then you have to add a node called tools, right? You can name it anything, right? But then you have to use a tool node from this pre-built LangGraph pre-built, right? And you have to pass the tools that you want to use, okay? And then you add a conditional edge, right? So from this assistant or a chatbot node, right? This conditional edge that I added, right? Now it uses the tools condition. Now this is also predefined in the pre-built LangGraph, okay? So now whenever the LLM says that or identifies that there is a tool call, it will call our tool node, right? Which is basically having these mathematical tools. Okay. The next thing is the patterns, right? So LangGraph allows the sequencing. So you can have steps 1 through n, one after the other. It also allows a router, right? So you can make a decision as to whether you want to go to node 2 or node 3 from node 1, as we saw in our simple graph, right? Now you can take this router further and make it an agent like we have done it here. So we basically added a edge back from tools to chatbot, right? So that makes an agent, right? So you can keep looping, right, until the agent decides whether to exit or not. Okay. Okay, the next thing is a persistence, right? So as we saw, there is a state and then we loop through the nodes, right, and keep modifying the state, right? But then what happens when the execution completes, right, and a next execution starts? So this is where this persistent comes in, right? So first one is in memory, right? So you have to use this memory saver, right, and you compile the builder with a checkpointer and you give it a memory, which is a memory saver. Okay. Now with this, what happens is, first of all, you have to use a config, right? You have to use a specific thread so that it uses the persistence, right? It remembers the last state, right? And now here I have said multiply that by 2, right? So if there was some computation that happened before, now it knows what was the result of the previous computation is to be multiplied by 2, right? Now that is possible only because of this persistence. Now uh, if it is in only memory, right, and if your program crashes or if it exits and restart, it won't persist, right? So now for that, there is a persistence to database also. Now with this SQLite, right, you can also use a in memory, right, with this colon memory colon, right? But for database, you basically give a database name and it will be persisted in the that file on the disk. Okay. Now, for this database persistence, you have to make a connection to the database, and you have to use the SQLite saver, and you give that connection. Right, so now use this memory uh, in your subsequent uh, checkpointer. So this checkpointer, when you give this memory, which is SQLite saver, it will go to database. So I have an advanced video on this persistence to database in LangGraph. You can see that also. Uh, it gives more details on this persistence to database there. Okay, one important thing, state, as we saw right now, this state can basically be a type dict. Right now, if you say type dict, you will access it as a Python dictionary. Right now, you can also use a data class. Right now, with data class, you access it with a dot. Right, so state dot name would access that field. You can even go more advanced with Pydantic. Right, here you have to derive from base model of Pydantic. Right now, you can add a field validator. So here I have said the mood can only be happy or sad. Now, so you can go more advanced with Pydantic. Now, there are some predefined state like this messages state from LangGraph graph, okay, that you can directly use in your chatbot, right? Okay. The next important concept, human feedback. So before we get there, let's talk about how to access the state and update it, right? So there is a method get state, that's how you get the state, and there is update state, right? So you have to obviously for both of these give a thread, which is the context, right? For the update state, you give what is the new content you want to push to the state. So I'm saying, oh no, actually multiply 3 and 3, right? Forget about previous computation. Okay. Now you add a dummy node like this human feedback. This pass is a no op in Python, right? And to the compile, you say interrupt before, right? And you give a node name. So whenever the execution is happening, it will interrupt there. Okay, now how do you execute? Right, so let's say I started off with multiply 2 and 3. Okay, now that is my initial input. Right, I have to create a thread, as I said, right, to have the context, and then you start the streaming. And now the streaming is started from the initial input, initial state, which is multiply 2 and 3, right? Now it will keep streaming. Now, uh, since there is an interrupt before, it will interrupt before that node, human feedback, right? Now, we ask the user, tell me how you want to update the state. Okay. Now, we updated the state by saying, no, actually multiply 3 and 3, right? Don't multiply 2 and 3. Okay. So now, after you updated, if you resume, right? So the way to resume streaming is you pass none, right, to this stream. So here we had passed the initial input. Now we say none, right? So now, since this is on that specific thread, it knows the context that it had executed until here, right? And now this stream mode has a couple of options. So we are going to use the values so that we print the values. Right, so now what would happen is multiply 2 and 3 would have executed until human feedback. Right, it updated the state by saying no, actually multiply 3 and 3. So now when you continue, it will give a result of 9, right, instead of 6. Okay, some interesting concepts related to this human feedback, right? So uh, you can also ask for a user approval, right? So you'll say that do you want to call the tool or not, right? So now only if user says yes, we'll continue, right? Otherwise we'll cancel, right? So this is a user approval kind of a human feedback, right? This is how you can implement it. Now there are also dynamic breakpoints, right, which are based on a condition. So here I have a node called step 2, right? And the way you kind of break dynamically is by raising this node interrupt, right? So just like we had this interrupt before in the compile, you basically raise a node interrupt. Now I'm raising this interrupt based on some condition, right? Which is whenever the input, the user input is having a length greater than 5. When somebody uh, sort of, gave input which is longer, right? I'm raising a interrupt, right? This is a dynamic breakpoint. Okay, another important concept is a time travel, right? So let's say you executed LangGraph through various states, right? Now, instead of getting current state, you can also get the complete history of the states, get state history. So it will give all the states it transitioned through until this point. Okay. Now you kind of, go back uh, 2 steps, 3 steps back, right? So let's say, oh, let me review my work, right? Kind of thing. So you can go back 2 steps, right? Now to replay, right, again you give a none, right? Now uh, since you have given a context of a thread, it knows it's a replay, right? It's not going to redo the operations, right? And again, I'm using a stream mode of values, right? So it will just replay it and it will give you the, it's kind of a review of the work you did, last 2 steps you did. Now, in addition to replay, you can also do a forking, right? So let's say you want to now redo, right? You say, okay, I reviewed, okay, I'm not happy right now, I want to change, right? So like we said, okay, don't multiply 2 by 3, but multiply 5 by 3, right? Uh, so that is also possible, right? So now the way you do it is you basically do a update state, right? But one key thing here is when you update the state, you give the ID of that message, right? So whatever multiply 2 and 3 was the message, and you want to replace it by multiply 5 and 3, but you have to give the ID of that same message so that it will get replaced. Now again, to resume, right, you give a none to this streaming. Right now when you execute, right, it will basically earlier execution would have one branch of tree, right, which was multiplying 2 and 3. Now we went back, say multiply 5 and 3, right? Now it will take a different branch, it will create additional branch in the tree of execution, right? And when you do this, you'll see 15, right? It will multiply 5 by 3. Okay, so if you like the video, click the like button, subscribe to my channel. You can see all this code on my GitHub, right? That I'll post as a link in the video, and see you in the next video. Bye.